Everyone. This is Sonu from Team Gray Interface, and I welcome you all to the first session of Study Jams by our team. And this session will cover the basics of Python. Now, before I get into the session, I would like to brief you all about the flow of Study Jams. So, we will have four sessions. The first session, which will be taken by me and my teammate Vrinda, will give you a brief idea about the basics of Python. We'll be covering Google Colab and basics of object-oriented programming. Then the next session will be about basic libraries that help you to manipulate and adjust data according to your needs. That will be taken by two other members of the team. The session three will give you a basic idea into data analysis and what are the common terms associated with ML. And by the fourth session, you'll be able to create your own ML model, a simple regression model. And yeah, so let's get into it. And first, we'll be learning about what is Google Colab. So it's a hosted Jupyter notebook, and you don't need to set up anything notebook, but it is hosted on the Google servers, and it has a lot of functionalities. It is extremely beginner friendly because all major libraries and the tools you need for ML are already pre-installed in it. And this is where we'll be writing and running our Python code. So let's get into it. So you need to type Google Colab into your browser, and once you log in, you will be met with this interface. Here, you can try reading the Welcome to Colab file, but we'll start with creating a new notebook. So we'll click on it. Now, this is what you see when you open a new notebook. Here is your file name, which you can edit. As you can see, there are a lot of icons here, and we'll be getting to each of them when need arises. So first you see what is here is a code cell. Now this is where you'll be writing your Python code, and if you click on it, I'll write a simple print hello. A simple hello world program. Now to run your code, you can do it by a number of ways. You can start by clicking here on this icon. However, using keyboard shortcuts is always a better practice. And for that, you can either press Shift Enter, which will run your code, and then it'll take you to a new code cell, or you can press Control Enter, which runs your code but keeps you in the same code cell. So I'll showcase that to you. If I'm pressing Shift Enter, I have created a new code cell. However, if I press Control Enter, I'm still the program has run itself, but I'm still on the same code cell. Now, along with the code cell, you see here when you hover over this area, you can see that you can create a code cell or a text cell. Now, this text cell can be used to just write anything you want in your notebook to highlight something. And this also you can create by pressing Shift Enter. Now, the specialty about Google Colab is that when you're running this code cell, it is not executing on your laptop but on the Google server. And there are different types of servers that are available, and you can see that by clicking on runtime, change runtime type, and this is where you see your server. So by default, your code is running on CPU, and for basics of Python, it is pretty good. You don't need to change your runtime server. However, as we go further, we'll have large models of ML, and they take a lot of time to run on CPU. Thus, we'll be using GPUs and TPUs, which are basically higher accelerators. However, since we don't need that for the session, we'll keep our default runtime type as CPU, and that's where our code will be running. And this is a specialty of Google Colab that it provides you with free GPUs in Colab and free TPUs. And this you'll use when you explore ML further and you create larger models. Now, however, if you leave your Colab file open for a long time, if you're not using it, then you get disconnected from your server. But it's a very easy fix. You just need to go on run time and click on run all, and this will run all your code cells. And yeah, that's it. Now, the reason we're using now, if we weren't using Google Colab to access various libraries and other tools, we'd have to use the commands pip install library name. But since we're using Google Colab, we don't need that. And suppose if you want to use a particular library, you can simply use import function to import that library because it is already pre-installed. And this is a big advantage of Google Colab. Thus, it is so beginner friendly that you can get started right away. Sharing of a Google Colab file is also super easy. You just need to go on File. You can either save a copy in Drive, you can directly upload it to GitHub, which I believe in your first session of GitHub you must have understood what it is. And you can download your file as a .iv, your Google Colab notebook as a Python file or as a Python notebook file. Now this is more used, it is more popular because it has more capabilities than a normal Python file. For example, these code cells are only available in a notebook. You can also change your order and do whatever you want with them. So when you hover over here, you see this down arrow that moves this code cell down. And if I want this code cell to come up, I need to click on the upside arrow. And you see, you can rearrange these files. Then you can delete your code cell, sorry. You can copy it, all these functionalities you can explore. Uh, in future sessions, you will be using what is called a data set. Now, you don't need to understand what that means right now, but simply if you want to load a file into your notebook, I'll tell you how to do that. You need to click on the file section here. Then you need to click on this icon and you need to upload a file. I'll be uploading a random file. You don't need to worry about what this file is and what it will do right now. That'll be covered later. But as I told you that once your session expires, your files can get lost also. So it's always good practice to mount it to Drive. This will ask you for connection to Google Drive. And yeah, this is how you upload a file into Google Colab. Since we've covered the basics of Colab, now we'll be moving into basics of Python, and you'll understand more about the language from my teammate Vrinda.
Hello everyone, my name is Vrinda Gupta and I'll be teaching you Python programming. So you must have made your Google Collaboratory IDs. So I'll be piecing together an overview of Python programming for beginners, emphasizing key concepts, basics, right? So see, Python libraries and ML basics and EDA will be covered in later lectures. In this lecture, we will be covering only Python, right? So we'll be covering variables, data types, control structures, functions, data structures, and in data structures also we'll be covering list, dictionary, and tuples. Okay. So for that you must have made your IDs on Google Colab. So before starting this, let's see, right, that what we are going to study. So introduction. Let's start with introduction to Python. See, it is simply a high-level language, programming language. It is user friendly, and why it is very much lenient is because it has libraries and frameworks which are built in, right? Means it already has written somewhere. Okay, so the libraries and frameworks are inbuilt in this. That is why this is very easy as compared to other programming languages. So talking about the applications of Python, it is used in the field of data science, machine learning, so and web development, web scraping, everything it includes, right? So learn very thoroughly so that you will not face any problem in future when you will be studying machine learning and right? And data science. So let's just start with programming it. Okay. So the first and foremost, I want to teach you a print function, which is used to print any output, right? So let's say I'm going to print hello world. This is the first code. So print, it will take a little time. Yes, see, it is printed. First thing is print, second thing is comments. This I'll be using from the starting till the end. So print function and comments. So talking about comments, the way to write comments in Python is by hash function. It's not a function. By using this symbol, you can write the comment. What is a comment? Comment is not printed on the output screen, but it is for your convenience, right? For example, if you want to know something about the code, if you're facing any issue, not getting it, so you can add comments in between. We'll be doing it in further lecture, right? So now I'll be showing you in further because now I don't have any comment to write in the sprint. Okay, so let's start. Print is completed. Now let's talk about variables, right? So I'll be writing it with variables. Okay, now printing variables. Let's say in C programming, you must have defined like we used to say int a is equals to. Are you getting my point? Int a is equals to 3. But in Python, we don't do anything like this. It is just s is equals to 3 and it is itself considering it as integer, right? So you don't have to define the data type before, right? It's simple. Keep it simple. S is equals to, let's say if it is a string, then you say Bob. Okay. Now using the print, let's say I'm using print and I say print S. So which will be printed? Let's see. The one which is updated will be printed because S, the value of S was 3. First it was integer, but then you assigned Bob in this. So the printed will be Bob. Let's talk about one more thing. Let's say, for example, you gave A is equals to 10, B is equals to 20, and then you said print A plus B, right? And then running it, it gave you 30, right? It is considering itself that 10 and 20 are integers. But if you say A is equals to 20, I mean 10, and then you say B is equals to 20, and then you say print A plus B, right? I'm going to run this. So it is printing 1020. So what is the difference between two is that in first one it is considering it is integer and in the second one it is considering it as string. So A plus B plus here is concatenator, not adder. But before in that cell I have used addition, right? And in this it is concatenating 10 and 20, both of them concatenated to form 1020. And also this is a string 1020, it's not a number, it's not integer, there's a string. Okay, so now let's say I define age is equals to, let's say I define s is equals to Bob, then age is equals to 25. Wait a minute, I did something wrong. Okay, now age is equals to 25. Let's say city is equals to Patna. Okay, now if I want to print all three of them, then I will say print s comma age comma city. Okay, and I'm going to run this. So it is printing in a single line. If you wanted in, let's say, different line. So if I say print s, then I say print age, then I say print city. So it will be printing it in three different lines, right? So the way you define it syntactically, it will become different. So let's talk about second thing. See, for adding the cell, for running the cell, shift plus enter I'm pressing. Okay, so what it will do, it will run the cell, and then only it will create the new cell. Otherwise, you have to create it from this code. Okay, if you have to write any text, then this text one. Okay, let's start with output formatting, the second thing. So how you get output is basically, let's say I defined amount is equals to 150. Okay, and then I say print amount is comma amount. So it is going to print amount is 150. So this is how you're gonna have the output, right? Now, now I'll be talking about F string. What is F string? Formatted string literals. So you can embed expressions within string literals using curly braces, right? Let's talk about F strings. I'll show you how it works. Okay. The full form of F string is formatted literals. Okay. Taking the above code only, I'm going to show you that how you will implement it, right? So print F amount is amount, right? Now I'm going to run this, and you see the output is same, only there is space. There is no space in this, right? So, so to add space, what I'm going to do is I'm going to put space over here, right? And then run it. So you'll see, okay, it is taking a little time. Let's talk about something else in the meantime, right? See, now it is implemented and it is having the same space as above. So I'll be using format now, and let's start with amount is equals to 150.8976. Let's say I took any amount of value, right? It's a float value. Okay, you don't have to define the data type, it will consider it itself. So print amount. Now from here, this is the format specifier which I'm specifying, and the column states that it is a start of the format specifier. Okay, now this 2f. What is this point 2f? This means till two decimal places, the floating point will be made. Dot format amount. So let's see what it will do. So simply it has rounded off till two decimal places. It was 150.8976 and the result is 150.90. It means format is for changing, right? For formatting the amount. You have to specify, first of all, that till which decimal place you want. Like I specified for 2. Let's say if I specified for 3, then it would have given for the 3 decimal places, right? Now let's talk about next, that is taking inputs. Okay. For taking input, you have to define, let's say x is equals to input, enter a value. Okay. So it is taking input, and then if I, sorry, then if I write print x and run this, so it will ask me the value that enter like 4, and then it will print that value. Okay, so this is taking input. But what if I want to take more than one input? Let's say x comma y I'm defining as input, right? Input, enter two values, one of x and one of y. So it is showing itself only. It needs to have dot split option. So what is the use of this split? It is going to split the values into two, x and y. Okay, otherwise it will not do that. Are you getting my point? So for single, it has taken the input, but if you want to take, if you want to have input for more than two variables, then you need to use dot split, right? Is that clear? So after that, taking the input, you have to print, let's say x comma y. Okay. Now giving two values 2 and 3. So it has printed 2 and 6, right? Means it has taken the values. So if you are not printing it like x or y, if you are printing it like only print x, so what it's going to do is it will print only 2, right? Like 2 and 6. So what it will do is it's going to print 2. So to split the values into x and y, I have to use dot split, right? Now let's talk about typecasting. Just a second. So typecasting, what is the meaning of typecasting? Changing from one data type to another, right? So changing from one data type to another. Now let's say I started giving with n is equals to int input which color, right? And in next I said print n. Now when I'm running this, let's say I gave this and now it is showing error. Now why it is showing error is it can convert only those input to integer which actually can be converted. It's written value error, invalid literal for int with base 10. How it's gonna convert red into int, right? So that is why. So if you have to delete it and I'm gonna write it again, let's say n is equals to, I have to convert it into integer, right? Input number. You can give it like a string also, and then you can change it, right? Print n. Now I'm gonna run it, and this time I will be giving input as 10, right? 10. So it gave me 10. Let's say, for example, if I had to change into float. So n is equals to float input number. Now I'm giving, now also I'm giving integer value, right? And we'll say print n. So let's run this. And let's say I will be giving 40, 56 in this. So it is returning me the float value, point 0, right? So this is what called as typecasting, changing from one data type into another. Okay, for example, now let's say a new thing, let's try something new. Finding the type, the data type, right? So let's say I gave A is equals to hello, then I gave B is equals to 10, and I gave C is equals to 9.89, I gave D is equals to A, comma, B. This is way of defining a tuple. This is how you declare, right? Let's say E is equals to defining a list. This is what list looks like, 1 comma 2, right? And now what I'm doing is I'm printing their types. So here I'll be printing print type A. So let's see what it will return. String. It has returned string, right? This class is a string. Okay, so the data type which A is storing is a string. Now if I say, let's say, if I want to print type of B. Okay, so see, Now, I will not run every, but let's say last I wanna run it. Type of E. So it is of list type. So this how you are gonna define list when we will study further. And this is a tuple. Dictionary also, there is a way to define dictionary also. Let me tell you. Okay, that is equals to key value. They are like key and then value. Okay, so this is how you define. And if I say type of F, right? Type of F. So it will show you dish. Just a second. Key value pair. Okay, I did something wrong. Just a second. See, it was because the last cell was not executed. You have to take care of this whenever last cell, if you make any change which is connected to the next cell, you have to first run it because it will not save the changes itself, right? And then you will run this. Now it will come correct. Okay, so it's going to show you dictionary. Okay, now I'll be talking about conditional elites. So I'll be explaining it with an example. Okay, so let's take age input is equals to input age. Okay, so now I've taken age as input, and after that, I am writing it. I mean, I'm typecasting it into integer value, right? So I'll say age is equals to int age input, right? Now after that, I'm going to apply if and else. This is the conditional state, right? So if I say age is smaller than 0, right? Now you need to be very careful while defining the syntax of if else, right? First of all, know this that in C we use brackets, right? But here we don't use. So if directly age is smaller than 0 and then you put colon. After that, when you type, when you press enter, so it will automatically show the indentation. Okay, if it is not showing the indentation, there is something wrong, right? Then you need to again put the colon, and then you need to again press the enter, right? So then after that, print invalid, right? Because age is smaller than 0, we have to be write it invalid. After that, see, indentation is very important. I'm repeating again. Why? Because if indentation is not correct, then it will show error. So after if, below that only, you have to write elif. Now what is elif? Elif is else if. Sorry, elif is else if. Okay, first of all, it will check for if condition. If condition does not satisfy, then it will go for elif. You can put as many elif as you want, and then at last you have to define else. Okay, so if I write age is smaller than 18, then again colon, after that print minor, print minor. Okay, after that, sorry, again if I say elif age is greater than 18, greater than equal to 18, right? Why equal to? Because there I have defined smaller than 18. So till 17 it will take. But what about when the age is perfect 18? So anything has to accept it, right? Otherwise 18 will throw error. That is why age is greater than equal to 18, and we use and over here. Like in C, you use ampersand. Sorry. In C, you use this symbol, right? But here we use and. So age is smaller than 65, right? If it is the case, sorry, I forgot the column. They are very important. print adult, right? After that, else statement. Every condition I have covered. Now only at last else condition is left. Else print senior citizen, right? Else senior citizen. Okay, so this is complete. Are you getting my point? I'm gonna run it now and it will say age like 67. So it will print senior citizen. Clear? Okay, so we'll talk about variables now. Till now, I was defining variables like A, B, X, Y. But let me tell you one thing. Variables like it can be amount also, like I have defined it. But variables cannot start from an integer like 1A is equals to hey. If I'm gonna run it, it will show you error. Why? Because variables cannot start with integer value. First thing. Second thing is that if I say A hyphen B and if I run it, right? It is also going to show you error. Why? Because only things which are allowed are numbers like digit, letters, and underscore. If I put underscore instead of hyphen, then it will accept it, right? Then it will accept it. Otherwise, it is going to show error on every other case. Never start with it with integer. Second thing is that do not use hyphen and do not use any special symbol, only letters, digits, and underscore. Clear? Okay, now next. The conditionals are based on specific conditions, right? So these statements help control the flow of a program. Are you getting my point? So this is what a bigger form I have written of conditional input. But there is one shorthand way also to write it. Let's start with this shorthand way. Shorthand is, see, you can give it in single line, right? So if you have to write it in a single line, then we'll say that, see, age is equals to, you have to give that value, or you can take input, this is your choice. After that, writing the conditional in single line, I'm going to show you that. If age is greater than 18, okay, then you're going to print eligible, and it will show you correct answer. Eligible because age was 19. You can give input also. If you give input less than 18, then it will show you not eligible. Means it will not print that. It will not execute the if statement then, right? Now let's talk about nested if else conditional statements. Okay, so I'm going to write like for example, I've taken age as 70, and if I have taken one more variable is member. I told you the rules, right? That is why now you should know why I have put this underscore, not anything else. Is equals to true. Okay, so after that, now if I'm going to start with, if age is greater than equal to 60, and in that I have nested another if, right? And if I say is member, correct? Then again colon you will put and write print, print A. Okay. Now, else, I will write in this indentation. See, if here I will write else below this, if yes. Otherwise, it will show error. Okay. Else, print, brief. After that, now what I will do is, if I'll put else below it. else print C. Okay, I'm gonna run this. So age is 70. This means it is greater than 60, right? And its number is true. This means it is going to print A. It's a simple example to show how nested conditional statements work. Okay. Now let's move on to loops. See, loops are used to repeat actions efficiently, right? Let's say if I have to write print A and I have defined A over here, just a second. A is equals to 10, then print A. Okay. Now I want 10 times, let's say. So I will write 10 times print A, and so on. Are you getting my point? So instead of doing that, what I can do is I can define a for loop for I in range 10 colon print A. Okay, and I'm gonna run it. So what it will show is it will show you 10 times. Okay, this how. And if you want it in a single line, then what you're gonna do is you're gonna put end is equal this. Okay, so we'll run it. See 10, but you need gap, right? So for gap, you can have like this. So this is how loops work. So this is one single loop. We'll talk about while. We'll talk about do while. Now let's talk about while. So while is used to execute a block of a statement repeatedly until a given condition is satisfied. Okay, so when the condition becomes false, the line after the loop is executed. Means it will come out of the loop, out of while. So let's start with an example. Like let's say I have count equals 0 and then I say while I is no count is smaller than 3. Not defined I, right? Count is smaller than 3. Count equal count plus plus. You know this, right? Count plus plus is count equal count plus 1. Count equal count plus 1. Okay. Now, this is increment operator, right? So it's going to increment the value by 1. So you're going to print count. Okay. So run this. Now let's talk about the next thing. Nested loops. Right. Wait a second. Just okay, sorry. Actually, this increment operator cannot be used in Python. It is like count is equals to count plus 1. It will show you error if you write plus plus, but in C, usually we write like that. Okay, so now see now 3 is printed. Now why 1, 2 and 3 they are not printed is because you have not written this print function in the while loop. You have not indented it correctly. So it's going to give you the final value of count. If you want it like 1, 2, 3, then you have to put this in the loop, means same indentation. So it is going to give you like this. If you want it in same line, then again, the same thing you have to do end, right? So now let's use nested for loop. For I in range 1 comma 5. So range is defining, so you have to define it from starting to ending. See, if you will not define it, if you will like 10, here it is like 10. So this means it is going to take from 0 to 9. Let's say I don't have to print A, I have to print I. Okay, I'm printing I over here. Let's see what happens. Till that, we'll write this code. Okay. Now, nested for loop I'm using for j. Sorry. For j, now see, the result is 0, 1, 2, 3, 4. This means the index starts from 0 if you are writing just 10. Okay. And ending at 9. 0 to 9, 10 digits. Are you getting my point? So you have to, if you don't want it to start from 0, you have to define it from 1 to 5. Okay. So in range 1 comma 5, you have to print value of I comma j, and I wanted a single line. So I will do like this. Sorry. Like this. Okay. Let's run it. So analyzing the result, see, I value is 1. For the first iteration, let's set the value of I as 1, and then j will iterate further for 1, 2, 3, 4, 5. So see, not, yes, from 1 to 5. So 1, j value 2, 3, 4. Now 1 till 4. So last index you define 5. It will be minus 1, index minus 1. Till that iteration will occur. Are you getting my point? So this is how nested for loop works. Now let's talk about loop control statements. So loop control statements include continue and break. Continue means that if you are applying it, then it will leave that particular part, and break will take you out of the loop. So let's see, implement it, and then we'll see the difference. So this is the code. The range I have chosen is 1 to 10, and I said that if I is equal to, this is the comparison operator, right? If I compare it, if I is equal to 5, you have to break. Break means you have to come out of the loop immediately. So as soon as 5, 1, 2, 3, 4, at 5, it has broken and it came out. While if I use continue with the same thing, let's say if I'm using continue over here, okay. So what it will do is it will leave 5. It will leave 5 and print every other digit. 1, 2, 3, 4, 6, 7, 8, 9. Okay. So 5 is left. So continue will leave that and break will move out of the loop. Now we have finished the conditionals loops part. Now we are coming with the data structures. So I'll be starting with the list, which is most important. I have covered this Python syntax and data types. Then I have covered loops and conditionals. Now I'll be starting with data structures. Okay, so list. So what is list in Python? It is built-in dynamic sized array. Okay, it means it automatically grows and shrinks. The same you cannot say for other data structures, right? But list, for list you can say that. It is mutable type. Mutable, you can change it. Means you can modify it, pend anything. Are you getting my point? It can also contain duplicates. So we can store all type of items in a list. It can also contain mixed type of items because it contains references and continuous locations, and actual items are stored in different locations. Right? I'm gonna explain you about tuples in dictionary, but later in the session. So let's talk about list. So this how we declare a list in Python, right? And you can even iterate it. It is showing. You can iterate it with this. So for item in shopping, what does it mean? That in the shopping list, it will go through each and every, like bread, coffee, sugar, separately. First item will be assigned to bread. second item will be assigned to coffee, and third sugar. And it's going to print that. So let's run it. So it has printed the list, right? I told you you can append in a list. So for example, if I want to append something else in the list, so I can do that. Let's say I'm appending curd, okay, and then I'm printing the shopping list. So print shopping. Let's run this. So when you want to print this, it will show you the fourth appended item only. One thing to notice that append will always append at last, right? If you want to change it in the middle somewhere, so you can change it like shopping. One is equals to iced tea. Okay. So the cell, but when you will print the shopping, it will show you the difference, right? Bread. Instead of coffee, it is iced tea. Okay, that is why we say it is mutable. You can change it. You can append anything. You can delete anything, right? Now, if you have to access the element, let's say I have to access first element. See, first element, I told you indexing starts from 0. Are you getting my point? Indexing starts from 0. So 1 will be the second item. So if you want first item, then you have to type 0 with this. Okay. Now, you can even insert, right? You can even insert anything at a particular position. So, see, you have changed it right here. Like 1, you assigned IST to this. Are you getting my point? But you can even insert it. Second option to do it, insert at, so this is the index at which you have to insert 1. And then let's say I want to insert oil over here, right? And I'm going to print it now. So print shopping. So what it will show you is that now it is oil. Okay. See, before it inserted twice, right? Now the difference between this shopping 1 equal iced tea and inserting is that iced tea will be the part of this list, but at first position oil will be inserted, right? I will tell you that why it was appearing 2 times. When I will again run this, it will show you 2 times. Are you getting my point? Because before, when the cell was there, so it executed it 1 time. Now it has saved it within itself. After that, when you again executed it, it again inserted first place oil. And you get how many times? The number of times you're going to run this, that many times it will add oil into it. Are you getting my point? That is why it was appearing 2, because I already ran the second time. Okay. So I don't want this thing to happen. I will again run this cell only. That shopping is these 3. And then I appended curd in it. And then assign first, the second element, iced tea. Okay, and I printed it. Right? Now let's talk about count function. So, for example, I defined the list as 12, comma 13, comma 89, comma 80, comma 67, and such like. After that, let's say I wrote 2 times 12. Okay, it is correct. List can handle duplicates, right? Now I am writing ages dot count, which number 12. So what it will return is that how many times 12 appeared in this list. Okay, so it will return 2. It is still running. After that, let's talk about len function. If I say print length of ages. What does it mean? It will print the length. What it will do is it will print the length of ages. Okay. Now there is another function, sort. What it will do is it will sort the whole list. For example, if I say ages dot sort, right? We'll run it and I print ages. So it will return in the sorted form. Okay. Now let's talk about very important concept, that is slicing. This is most important. Okay. Even while learning the data set, while further lectures, it will help you a lot, slicing. So let's define a list. I'm taking a list of numbers to explain it. Let's say I have taken this list and now I will start. What is slicing? Slicing is basically you cut slices, right? If I want a few indexes to be printed, let's say I want 2, 3 to be printed or 4, 5 to be printed, something like that. So I need to give the starting index and the ending index, right? So this concept is slicing. Okay, taking the small part out from a list. Now understand the syntax which is used for slicing. You can see this print. Now I am for accessing those indexes, you have to use colon. Before colon, there will be part which is a starting index. And after colon, it will be the ending index minus 1. Let's say 1 to 5. Are you getting my point? So in this, see very carefully, we are starting from 1, means the 0th index, that is 1, is left. We are starting from 2, then 3, 4, 5. Actually, if it would take 5th index also, then 6 would also be printed, but it is not. This means that the starting index and the ending which you are defining should be plus 1. If you want 6 also, then you should define 6 over here. Are you getting my point? It will take 1 to 5 should take 5 elements, but it is taking only 4 because it is a syntax. This is end minus 1. Okay. If it is not defined anything in the starting index, it will take from the very starting, means 0th index. And let's say if I don't define this also. So what is going to do is, it will print whole list. Right? So this is for whole from starting to the very end. But if you want, let's say, to access it, so you define starting index and then you left the ending index. It means it will take the whole list from first index. It will leave the 0th one and from first it will start. Okay. Similarly, if I have to start from the very starting and end at some value like 6. So it will start from 1 till 6. Okay, 5 elements it will take. It will leave the sixth one, that is 7. Okay, now let's say you don't want to access continuous locations, right? You want to access, let's say, the real was this 1, 3, 5, 7. Are you getting my point? So, what you are going to do is, so see this syntax. The first is the starting index, then you define ending index, and then you define the number of steps you have to take ahead, right? For example, you started here from first index. This means you will start from 2. Okay. After that, what you're going to do is you will leave 3. You will enter 4 with this. Okay, because 2 is defined over here. Agar if I would have defined 3, then it will change accordingly, right? It will access every third index, starting from the first one and ending on 8th one. Okay, now understand one more thing very carefully. Like, for example, this is the list, and I'm starting from 0th index 0, 1, 2, 3, 4. Till that, I will go to end, right? Now, if I have to define in the reverse order, so you should be You should know that this ninth is having -1 index. So if I want to access 9, then I will write -1. Similarly, -2, -3. Because 0 is defined here and +0, -0, we cannot define it. Right? So what we are doing is we are defining the last index as -1 and it will go on. Okay. So if I have to reverse the list, let's say, so what I'm going to write it from starting till end, you have to put the gap of -1. If you write -1, then it will start from the end. And at every -1 distance, it will print it. So it will reverse whole list. See, it has reversed, right? Now see another example. In this list, if you want to access elements from -5, so -5 is the starting index. Let's go there. The list was defined. Okay, so -5. What does it mean? -1, 2, 3, 4, 5. So this means the starting index is this 5, right? And till -2. So -2 is what? -1, -2. So 5, 6, 7. Why? Because last say 1 before, right? And -1 index. Again, I'm telling you. Now, list is complete with slicing. Let's start with another topic, that is dictionary. Okay. See, it stores the values in key and value pairs, right? See, value can be of any data type. Okay. While keys, know that the value of a particular key which is defined cannot be duplicated, right? Key value pair, in that value can't be repeated and it is also immutable. While keys, on the other hand, they are mutable. You can change them, right? You can duplicate them. Okay. So let's see how we define, not define, how we initialize it, right? So if you have to initialize empty dictionary, then you can do like this. But we'll write something in this. Okay. I'll write like this. See, this is the key, then colon, then value. So value is, let's say, mine. Okay, then comma, again second key, then again value, name. Okay, then again key and value, right? So this how I initialized a dictionary, right? Declared it actually. Now same thing in this also. You can print the dictionary by using print d. Okay. So how you access element in a dictionary is simple. Just enter the value of, just enter the key and value will be returned, right? You can even try updating and adding dictionary items. Let's say, if I say that D2 is equals to hello, okay, and then I print the dictionary. So now it will update the value of the key 2. Okay, because you mentioned the key 2, so it will update the value to hello. Now let's say if I have to add it. So I will say d of 6 is equals to every. Okay, and I will print this d again. So it has added a new key value pair. Okay, so dictionary is this much only. Now we will start with tuples. I will tell you a little about tuples. It is similar to list, just the difference is that it is immutable. Okay. So accessing elements and all that, I'm not going to tell you. It's just, I will tell you how to initialize it and rest is same. As tuples are immutable, you cannot use append, insert, remove, pop, sort, these things. in a tuple, right? While these can be used in a list, which I've already told you. So this is how you declare a tuple. My name is, you don't use curly braces, you don't use square brackets. There's a different way to define a tuple, that is simple brackets you're using. Okay? Using list also you can declare tuple. Like for example, if I have to define a list 1, comma 2, comma 3. And after that, sorry, 1, comma 2, comma 3. After that, I will say print tuple li. So it will print it in the form of a tuple. Okay, it has printed. After that, you can also, this is using list. You can also use built-in function, right? Like tuple day. Okay, then print. Okay, so it has taken each and every character and printed it like that in a form of, it is using a built-in function, right? Now Sonu will be taking from here. She will be telling you about object-oriented programming and the concepts related to it, like polymorphism, inheritance, and a little of that, right? Okay.
Topic that we'll be covering is functions in Python, and in the most basic terms, functions is a reusable block of code which performs a specific task. So suppose in my program, I want to run something. Uh, I want to perform, suppose, an operation, but I want to perform it multiple number of times. So instead of copying the logic, the code of it multiple times in my program, I will wrap it into a function and I will call that function wherever I need to run that program. See, if I copy paste the same code many number of times, it is a huge headache because your code is bulky. If you suppose in the future you see that you have made a mistake in some part of the code and you want to rectify it, you will have to rectify it in all parts of that wherever you have copy pasted the same code. So it's always better to make a function and use that function so that even if you want to update, delete, insert, whatever you want, you have to do it in one place and then you can use that in the future. There are two types of functions, built-in functions and user-defined functions. You have come across many built-in functions. For example, the most common one is print. And I'll show you how to make a user-defined function. So first you use the keyword def, then you write your function name, then you put in parenthesis, and what this does, I'll tell you later. But then inside the function, you write whatever you want to perform. I have made a simple function to greet someone which says hello. And then you write the function name whenever you want to call that function. So this is called a function call. So your flow of execution is wherever you see this function, it will go inside this function and it will perform that task. So you can call it multiple number of times and it will do the same thing. See, instead of having to print hello, I just had to call the function twice. And this code is very small. That's why you might be thinking, what's the point of making a function? But oftentimes your code is very big. The logic behind your code that you want to perform is huge. And you cannot go on copy pasting that same code everywhere you want. Now we'll learn a little about arguments and parameters. So if I want my function to do something on a particular value, I will pass that as argument to my function, and that is what comes inside my parenthesis. Suppose I want to make a function. Suppose I want to make a function that calculates the average of two numbers A and B. I will pass those as arguments. Then I will perform whatever task I want to, and then I can either print or return that value. So whenever I call this function, it is going to go inside the function, perform the operation with whatever parameters I have given here, and then it will return the answer to me. For example, average of 5 and 4 is 4.5. So you can also give default parameters. Suppose you want to give A as 6 and B as 7. So if you don't give this parameter here now, and if you try running this function, It'll still run and it'll take these values as default. You can also give particular values. Suppose if I just give 4, one value, then that'll take A as 4 and B's default value will be 7 and there'll be no error in this code. If I want to give a particular value for B, I'll have to write B is equals to, for example, 19, and this will also not give me any error. So this is how you can give default parameters to your arguments to your function. Another thing that everyone should know about is the difference between print and return in a function and when to use them. So print is it is a built-in function, right? It is used to show whatever you want to the user. However, return is a keyword and it returns the value that you have in front of it to the caller. It's not showing anything to the user. It returns a value to the caller, and wherever you call that function, the flow of execution will go like, suppose if I have, for example, let's consider this code where I have used return keyword. Now your flow of execution is somewhat like this. It comes from here and it goes down. This is your flow of execution. However, when you come at return average, your execution is stopped after that. Learn about what are recursions. A recursion is basically a function which calls itself. So you have a function and inside that you are calling the same function. So it's sort of like a loop kind of situation, you see. Let's start by coding it first. And a very common example of a recursion is a very simple factorial calculating function. So let's code it out first and then I'll explain the code to you. Let's make a function factorial of, and I'll pass the argument n. So basically I'm taking a value n. Now we know that if your n is 0 or 1, your factorial is 1. So let's take that base condition. If n is 0 or 1, then I'll return 1. But otherwise, I will return n into factorial of n minus 1. Okay. Now I have the function factorial of n. And inside this function, I have used factorial again. So this function is calling itself. So the flow of execution is, suppose you have factorial of 4, let's say. Now 4 is not equal to 0 or 1, so it will come into the else loop. Now what will happen is n is equal to 4. Here you have 4 into factorial of n, sorry, into factorial of n minus 1. So factorial of n minus 1 is factorial of 3. Now again factorial of 3 will come inside this function. So you have factorial of 3 that will give 4 into 3 into factorial of 2 into factorial of 1. And so on like this, you're calling the function repeatedly inside a function. That is called a recursion. And I call this function. Suppose I want to find out factorial of 4 and run this function. I'm getting 24. So to help you better understand this, I'll insert a picture here. See, look at this picture. You will understand what recursion is. So you have your function which starts at factorial of 5. Now inside that you are multiplying 5 into 4. Now 4 factorial you have to find out. So 4 factorial will again go into the function and it will find 3 factorial. Then that 3 factorial will go inside the function and find value of 2 factorial. And so on, it will reach the base condition where your value is 1 factorial and it will return 1. So here you have 1 now. Now this will go here, and 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 it will return the value 5 into 24, which is 120. So this is how recursion works. So we know what recursions are now, and a recursion is used in a lot of problems. For example, factorial is one. Then for Fibonacci series also we use the concept of recursions. Fibonacci series is you start with 0 and then the next 0, 1, and then the next element is the sum of the first two elements. And the next element is the sum of the last two elements, and the next, and so on.
So you can try doing the Fibonacci series question as homework, and that'll help you understand this concept better. Now we'll be moving on to object-oriented programming.
So this is it about functions. You can explore more about functions in depth. You can use the resources that we provide you with. You can try out different questions, and yeah, that's it. Starting with object-oriented programming, and till now, everything that we have discussed has been part of procedural programming. So the basic idea of object-oriented programming is using classes and objects, and through which we represent real-world entities. Now, what is a class? A class is a template code through which you create objects. Let's take an example. If I have a form to fill, suppose I have some form. Now, a form will have some information along with many blanks. So it's telling me what to fill. For example, it'll have the name column, and there I'll have to put in my name. Then it'll have my age and all information about me. Now, this form is dictating me what to put inside this form. So that is what your class is. It is a template which helps you create objects. Now, if I'm filling the form, suppose Sonu is filling a form, then I have become the object. If another person is filling the same form, then they are a different objects. However, the things inside the form, for example, name, age, and all these information, they will be the same for the other person. The values of these will be different, but these are the basic methods that are in both the classes. So every object, see, as you can to help you better understand these concepts, let's take an example. Suppose I have a class which is called a person. I'm making a person class. And now inside that class, I'm putting some properties which are first your name and your age and your gender, for example. Now this class also has some methods. For example, a person eats, a person speaks. Now these are different methods. So now each instance of my person class, this is a unique object. Like there's a one person, there's the other person, Sonu, Vrinda. These are all different unique people, but they have the same methods. Every unique object has the same method. For example, Sonu also speaks. Sonu also walks. Sonu also eats. So this is the basic idea of classes and objects. And now we'll try to code it. Now we'll start with how to create a class. First, you need to use the keyword class, and then you need to give your class a name and make sure your name is in Pascal case. That means the first letter of each word is capital. For example, I'm creating a class person, and in that I will give some attributes to the person. For example, name, age, and let's say gender. Now, if I want to create an object of this class, the syntax of that will be object name is equals to class name and brackets. So now this I have created an object by the name object1. Now if I want to access a particular attribute of this object, I can do that by printing object dot parameter name. For example, I want to see what is object's age. It shows 19. Now if I create another object, let's say object2, and I want this object to have a different age. Let's say I want this object to be of age 20. I can change that by doing this. Object name dot parameter is equals to set it. And now when I print the age of this object, I will get the new value. Print object2 dot age. So you see it was 19 for object 1. However, it is 20 for object 2. So you can set it using this.
Now let's see if I want to create a method in my class, and what is the self parameter.
A method in my class, for example, I'll create an info method. Then I'll have to use this word self. Now what it is, I'll tell you, but let me write the code first. And I want this to print name of object is self dot name and age is self dot age. Now suppose I call this method for both the objects. Int object1 dot info, object2 dot info. When I run this, I'll get that name of object1 is Sonu and age 19. However, for object2, the age is 20. I can change the name of object2 also, but that's not required here. What you need to understand is the self parameter. Now, in basic terms, self parameter is a reference to the current instance of your class. I'll repeat myself. It refers to the current object of your class, and you can use this to access variables of your class. For example, when I am calling this info method for object1 over here, then inside this, the self.name refers to object1.name. And when I call it for object2, self.name refers to object2. So for whichever method you are calling, for whichever object you are calling a method, this self parameter will point to that object. I hope this is clear for you, and you'll be able to understand this better when you understand what constructors are as we move along. What constructors are in object-oriented programming. And constructor is basically a special method inside a class that always gets called whenever an object is created. And why do we use constructors? It is used to easily initialize attributes. You can directly do that. And let's see how we can code that. So we'll use the same example as the previous one, a class person. And for constructor, you need to write this syntax. You need to create a method in which you use the keyword for creating the method, then underscore underscore init underscore underscore. This is initializing. And then in brackets, you need to give the self parameter. You can also give different parameters, uh, whichever you want. But for now, let's assume there are no other parameters. And the way to do this is self dot attribute name is equals to value. So this is how you write, this is how you make a constructor. For example, example, in the previous example, we had name of a person. So self dot name is equals to whatever value I want to give. So no. And self dot age is equals to 19. These are all default values I'm giving, which can be changed later however you want. And self dot gender is equals to female. So this I have created a constructor here, and I have used that to initialize my attributes as you can see here. Now if I create an object, for example, object1 is equals to person. And if I try printing this person's name, all I have to do is object1 dot name. And just like in previous examples, you can also you can change these values. For example, if I see, I've gotten Sonu printed. If I want to set the value as something else, for example, I want the age to be object1 dot age is equals to 30. I can do all that, but it's the same as previous logic. All we've done is created a constructor, and this constructor is always called whenever you create an object. So suppose let's say I don't want to print this, I am creating another object. The number of objects you create, that is the number of times your constructor is called. Since I'm not printing anything inside the constructor, nothing gets printed. But every time you've created a new object, your constructor is being called.
So, everyone, that'll be all from our side. My teammate Vrinda and I thank you for attending our session. We'll be uploading some resources in the description of our video that you can check out. And do try to explore this domain further and also attend the next sessions because they'll be very informative for all of you. And yes, that's all from our side. Thank you and signing off.